Hello, everyone. So let's talk about how to sort our custom collection. And by that, I mean that suppose that we have an employee class, and that employee class has a couple of attributes, the employee name and employee salary. Now, what I want is that I want to have a collection that can be sorted based upon, let's say employee salary. Okay, so what I will have is that I will have an array list, and I want to insert different employee objects in that list, and then I want to have a mechanism which allows me to sort different employees. Now, how would you define that way of sorting? It depends totally upon you, but right now I'm saying that the employee should be sorted based upon his or her salary. In that case, what I need to do is basically, once I have defined an employee class or any other class, I can have an interface, a customized interface that allows me to compare two different employees. And then I can compare those employees based upon their salaries. For example, I can say that if the salary of employee 1 is less than employer 2, then return -1, otherwise return 1. If it's other way around, or if the two employees have the same salary, then return 0. So this is a generic so I'm implementing a comparator interface, and this is generic in the sense that I can implement this in comparator interface for any type of object that I want. And then I can say that create an array list of different employees, and then once I have let's say once I want to sort my array list, then I can simply create a new interface of this comparator class that I've defined myself, and then use that interface as an argument to this sort method. And now your employee array will be sorted based upon the custom comparator that you have defined yourself. So this is one way of doing that. That is, just keep adding employees in that array list, and then define a custom comparator interface, and then call the sort method by passing the custom comparator interface in this sort method as an argument. The second way of doing that is basically, if you remember, we studied these associative containers, which actually insert your elements such that during insertion, the element is inserted in a particular location of a binary tree, such that when you query that item, it is already inserted in its correct position in that sorted list. Okay, so this is what happens during insertion time. The tree itself maintains a sorted data structure during insertion, unlike our previous approach where we insert at any place and then run that sort method afterwards, once our array is is already fully and finalized. Then we call this sort method. But here we actually insert our particular item in a particular location. Now, how are we going to do that? We are going to see in our next class when we study tree. Okay, but this is just a heads up that this is also a second approach that we can follow for maintaining a sorted data structure. Right. And likewise, we can also have, let's say, just like we have maintained sorted data structures, we can also have unique collections of different objects. And what is meant by that is that I can have, for example, let's say the same employee class, and then what I want is basically to have a hash set or a set of different employees, imagining that this hash set or this set of employees can only contain unique employees. Now, what is meant by unique employees, once again, this depends upon myself and I'm going to do right now is basically define an employee, or let's say identify an employee by having some unique hash code. And in that hash code, what I'm going to say is, let's say two employees are the same if they have the same name and they have the same salary. Okay, so if both, let's say if two employees have the same name and they also want the same salary, then basically those two employees are equal. Okay, so what I need to do is basically override this hash code method that exists for every object in Java. And the second method that I need to override is this equals, which allows me to call this equals method on any object of type employee. Okay, and what this does is basically, if there are many checks, for example, if this is the same object, then return true. If this object is null, obviously, then there's no way of comparing this particular object with this other object that I have received. And then if the current object has different class than the other object, then also this comparison should return false. And then only if uh, the other object that I receive is typecastable to this employee object, and then both of these objects share the same hash code, which means that they share the same name and salary, only then this function should return true. And then so these are the two methods, the hash code method and the equals object method that I need to override for my particular class. And then I can have a hash set of employees where I can simply add different, so this is not an array, this is a hash set. Okay, so apologies for this naming convention. And then I can, so once I have this hash set, I can add different types of employees. And once I insert the same employee twice, and by same employee I mean for example, this employee having the name Neha and salary 52 is inserted twice, but once you print it, you'll see that this third insertion actually doesn't have any effect on this hash set. Okay, so once an employee exists, if you add the same employee with the same name and salary, then this means that this employee has the same hash code, and so this defies the uniqueness constraint of your hash set, and so therefore this line does not have any effect, because your hash set is supposed to contain only unique objects. Okay, so this is how we will define the uniqueness constraint of our custom objects and use that constraint within a hash set. Okay, so in the next video we are going to see binary trees and how those trees are fruitful in implementing sorted data, sorted customized objects in Java.